In this video we're going to look at how we can create trigonometric graphs, that is graphs of y equals sine of theta or sine of x and y equals cosine of theta, that's cosine of x. And we're going to look at how we can figure out the maximum and minimum values, something called the amplitudes, and then the initial values. What we have here in this window just here is a video from GeoGebra, and what's going to happen is we're going to move this point here, right, so that we create an angle, and this angle is going to increase, and as we watch the angle increase we're going to look and take the y coordinate of the point on the unit circle and take that y coordinate, it's the cosine of whatever the angle is, the sine of whatever the angle is, and plot it on this graph. Okay, so we'll do that now. So you'll see that we're going to take this angle and increase it, and as we're doing that we can see this angle in here increasing, and what's happening is that the coordinate here is increasing accordingly. So whatever the y coordinate here is, that's what the sine of the angle is there. So when I get to 90 degrees here, the y coordinate, that is the sine of 90 degrees, should be up at 1. So when I increase that to 90 degrees, you can see now that we're up at 1. And then if we continue on, by the time we get down to 180 degrees, then the y coordinate, the sine of 180, should be 0. And if we go around to 270 degrees, the y coordinate at this point here is -1, so the sine of 270 is -1, and back to 360. And we could continue on, and do that again, go round another 360 to 720. So the graph, yes, would be continuing on in this direction here. So just let's look at some of the features of that graph that we've obtained. The period is the distance between the start and the next start. Now what I mean by that is that if we started here, we have a whole kind of cycle and we get back to the start again. So the period is from here across to here, that's 2 pi, or another way of thinking about it is that it's 360 degrees if we were working in degrees. Okay, so the period you could equally well measure from one maximum to the next maximum. From here to here would also be 360 degrees, or it could be from a minimum to a minimum if that's what you see. In any case, the period is going to be 2 pi. The maximum, by maximum I mean the maximum y value, is going to be at 1. Right? This point here is the highest that it gets, so the maximum is going to be 1, and the minimum is going to be at -1. The minimum is at -1. Okay, so the maximum is 1, the minimum is -1. And the last thing to say about this is to say what the initial value is. The initial value right here is 0. When the angle is 0, the y value is 0. Now the other thing that's worth mentioning here is called the amplitude. The amplitude is the vertical distance between the top and the bottom divided by 2. In other words, it's the distance from the middle up to the top, and that distance is just 1. The amplitude in this case is just 1. It's half of the distance between the top and the bottom. In this case, the amplitude is 1. Now the second thing we have here is a graph of the cosine of x, or the cosine of theta. Now the thing to notice is that with the cosine, when we start with an angle of 0, which we have right here, the x-coordinate, the x-coordinate on the unit circle is going to be equal to 1. So we start way up at 1. And then think about what happens to the x-coordinate as we go around this circle. It's going to get smaller and it's going to go towards -1. It's going to be -1 when the angle is 180 degrees. So what we're expecting is that when we get to 180 degrees, somewhere down here, we should be at -1. So let's just see what happens when we play this video. We're going to start right now. So we're starting to increase the angle, and you'll see that the x-coordinate on a unit circle is getting smaller. By the time we get to 90 degrees, the x-coordinate should be somewhere pretty close to 0. Right? So it's 0 there. And then if we continue on, if we continue to move the angle on, we get a lower and lower x-coordinate. So the x-coordinate when we get to 180, you can see there, is -1. And then it starts to increase again. The x-coordinate is now getting close to 0. At 270 degrees, the x-coordinate is 0. The cosine of 270 is 0. And then back round to 360 degrees, we will get back up to the cosine being equal to 1. And of course, this could continue on. We could continue to go round again. And if we go round again, we'll have the same cycle repeated, and we could go around as many times as we wanted to. Now, just looking at this graph will give us some information about the maximum, minimums, and so on. So again, the period of a periodic function, and these trig functions are periodic functions, is the horizontal distance that it takes for one cycle to take place. So one cycle would be, for example, from here to here, or it could be from here to here. If you go from here to here, that's 360 degrees or 2 pi. Likewise, if you go from here to here, that again is 360 degrees or 2 pi. In other words, the period here is 2 pi. The maximum again is going to be up at 1. The minimum again is going to be down at -1. So the same thing for the maximum and the minimum. The maximum is going to be 1 and the minimum is going to be -1. And the other thing to say about this is the starting point. Now that's what's different about the cosine. For the cosine, we start at 1. Whereas if you remember, when we had the sine function, we started at 0. We started at 0 and we went up for the sine. When we have the cosine, we start at 1 and we go down.